Welcome to today's video on Cambridge IGCSE Mathematics 0607 and 0580. The topic for today is functions, where we will be focusing on the subtopic domain and the range of functions. To begin with, we're going to talk about function notation. Function notation is the standard form and the standard symbols that we would be associating with functions when we represent them mathematically. So function notations helps us to describe lengthy functions in a much simpler way that is pretty easy to understand. Now, when we have a function, what a function generally does is it takes an input. And if you put this input into your function, I'm just going to denote that with the letter F here, it's going to use that input, process it, and give us or generate an output from it. And when we have functions, we would be able to see it being denoted like this, where a function would be shown with f, and inside brackets, you'll be able to see x here. Now, this is read as f of x, or the function of x. And this can also be shown using these symbols over here, where the arrow is indicating that an element from our function of x is being mapped on to the range y. Now, when we have functions, we have a domain and we have a range, and a domain is a set of all inputs for which the function has defined outputs. And on the other hand, the range of our function would be the set of all possible outputs that our function can generate. So if we look at this here, if we have something that says y is equals to x squared, and if I want to write this in terms of a function, instead we would write this as f of x is equals to x squared. And you can see here that we replace the y with f of x, or the function of x. When we deal with functions, something else that we would notice quite frequently is mapping diagrams. Now, mapping diagrams are similar to flowcharts for functions, and this helps to show input and output variables in a diagram format. When we show input variables, the inputs for which our function have defined outputs, we call this the domain, like mentioned before, and the range is the set of all possible outputs. So in this case, in my first diagram, I can see I have different elements in my domain, and each of these different elements map on to just one element in my range. And because of this, we call this a one-to-one mapping diagram. On the other hand, if I look at the diagram that we have over here, I can see that the element A maps on to not just one element in my range, but it maps on to multiple elements in my range. And because of this, I can call this a one-to-many mapping diagram. We also have a third form of a mapping diagram, and we can refer to this graph to show that here. And this third form of mapping diagram usually is generated when we have ordered pairs. Now, ordered pairs are generated with coordinates, because when we look at coordinates that are coming from a Cartesian plane, these have x coordinates and y coordinates. And when we give them in terms of pairs. So if we look at the relationship here, we can see that the set R is a set of coordinates, which are 1, 2, 2, 2, 3, 3, and 4, 3. And if I look at the inputs or my domain, then this is the set of all of my x coordinates. So the x coordinates that I have from here is 1, 2, 3, and 4. On the other hand, the range would be all of my possible outputs, which are the set of all of my y coordinates. And if I look at the y coordinates that we have here, I can see that I have 2, 2, 3, 3. So basically, that's the numbers 2 and 3. If I convert this into a mapping diagram where I have the domain on one side and the range on the other, I can see that multiple elements from my domain can map on to the same element in my range. And this is called a many to one mapping diagram. So although we have discussed three different types of mapping diagrams, that's one-to-one, one-to-many, and many-to-one mapping diagrams, when we deal with functions, functions can only take place in two separate types of mapping diagrams. That's when we have a one-to-one function or a many-to-one function. To go over that again, a one-to-one function is where every element from our domain maps on to just one element in our range. And a many-to-one function is where multiple elements in our domain can map onto a single element from our range. Let's consider the mapping of y is equals to 5x minus 2. Now, in this case, if I write this in terms of a function, I can say f of x is equals to 5x minus 2. And then I can work out different variables for x. That's my input. And this would be the elements from my domain. And the response or the output that I would get from my function of x would give me my range. So if I use -2 in this equation, I would be able to work this out. So 5 times -2, take away 2. So this is going to be -10, take away 2. I'm going to get the answer of -12. So the element -2 from my domain maps on to the element -12 from my range. And I can do this for different sets of x values. So we have done this for 3, 5, and 6, and I can see these generate different values for my range. And looking at this mapping diagram, I can see that this is a one-to-one mapping diagram, which means that we can write this as a function. So that's all we have on today's video. Thank you.